Hello everyone. Welcome to the solution of LeetCode problem 42 named tapping rainwater. In this problem, we are given n non-negative integers representing a elevation map where the width of each of the bar is 1. And we have to compute how much water it can trap after raining. Suppose this is the first example. Here we can see that if the rain happens, it can contains 1 unit of water here, 1 unit here, 2 unit here, 1 unit here, and 1 unit here. So there are 6 units in total. So for this input, we have to return 6. Anyways, the constraint of this problem is the array length can be in between 1 to 10 to the power 4, and each of the array elements can be in between 0 to 10 to the power 5. Anyways, the problem statement might seem a little bit of complex right now. I will explain it right after in the next section. Here, if we consider the first example, according to the problem statement, there are some bars and the rain happens from the top. So here, if we notice that if the water falls from the top, then 1 unit of water can be present here. 1 unit of water can present here. 2 unit of water can be presented here. 1 unit of water can be presented here. And 1 unit of water can be presented here. So here we can see that there are total 6 unit of water this map contains. So this is the brief problem explanation. I hope you understood the problem. Now, let's move on to the algorithm. Now, the algorithm is pretty simple. For each of the cell or each of the element, suppose we currently presented at here. Now, for each of the cell, we have to check what is the maximum height in the right and what is the maximum height in the left. After that, we have to take the minimum of them and subtract the original height. Suppose for this cell, the maximum height in the right is 2, is 3, which is this, and the maximum height in the left is 2, which is this. So the minimum of them is 2. Now we have to subtract the original height of the ith element. Here the original height is 1. So we have to subtract 1 from 2. So the answer will be 1. So that means this cell can contains 1 unit of water. So here the algorithm is pretty simple. We will take 2 extra arrays. 1 extra arrays will store all of the value from the left side and the maximum of them. And 1 extra array will contain all of the maximum value of the right side. Now, in each iteration, we will subtract the original height from the minimum of them. After that, we will get the result. So here in this problem, at first, we will take 1 array, which is max L. That means maximum from the left. So here, for the first element, the maximum is 0 because it does not have any other left element. For this element, the maximum element is 0 from the left. For this element, the maximum element from the left is 1. For this element, the maximum element is 1 from the left. For this element 1, the maximum is 2, which is this. For this element 0, the maximum is 2. For this element 1, the maximum is 2. For this element 3, the maximum is 2. For this element 2, the maximum is 3. And 3, 3, and 3. So here, for each of the element, we have calculated the maximum in the left element from this element. Now, we will take another array, which is maximum of right. Now, for the last element, 1, the maximum element in its right is 0. For this element 2, the maximum element is 1. For this element 1, the maximum element is 2. For this element 2, the maximum element in the right is 2. For this element 3, the maximum element in the right is 2. For this element 1, the maximum element in the right is 3, which is this. And for this element 0, the maximum element in the right is 3, and so on. And all other elements has the maximum of 3 unit in the right. Now, we will take the minimum of them. So here, the minimum of 0 and 3 will be 0, 0, 1, 1, 2, 2, 2, 2, 2, 2, 1, and 0. So this is the minimum array. Now we have to subtract the original size from the minimum array. So if we subtract, before subtracting, let us again rewrite the original array for the simplicity. The original array is 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, and 1. Now, if we subtract the minimum value, so the subtraction will be 0 minus 0, which is 0, 0 minus 1, minus 1, 1 minus 0, 1, 1 minus 2, minus 1, 2 minus 1, 1, 2 minus 0, 2, 2 minus 1, 1, 2 minus 3, minus 1, 2 minus 2, 0, 2 minus 1, 1, 1 minus 2, minus 1, and 0 minus 1, which is minus 1. So here we have found the subtracted array. Now here, if we notice, the positive value are this 1, this 1 to 1, and this 1. So here the summation of all of them is 1 plus 1 plus 2 plus 1 plus 1, which is 6. So here we can see that this 1 represents exactly 1 unit of water here. This 1 represents exactly 1 unit of water here. This 2 represents exactly 2 units of water here. This 1 represents exactly 1 unit of water here. And this 1 represents exactly 1 unit of water here. So here, let's wrap up the algorithm. The algorithm is pretty simple. At first, for each of the element, we have to calculate two things. What is the maximum element in the right and what is the maximum element in the left. After that, we have to find the minimum and subtract the original value. After that, if the subtraction value is greater than 0, that means we have to add this value to the answer. And finally, we have to return the answer. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named tab, and we will take 2 extra arrays to store the maximum value from the left and from the right and initialize them with 0 initially. After that, we will run a loop from 1 to n, where we will store the maximum value of the left, and again, we will store the maximum value to the right by using another loop. After that, we will run another loop from each of the element And in each iteration, we will calculate the value of water in the ith positions or in the corresponding positions. So here, the value of water will be minimum of the maximum value from the left and the maximum value from the right, and subtract the A. If the water value is greater than 0, then we have to simply add the water value to the answer. After that, we have to return the answer. So this is the algorithm and the code. I hope you understood this code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we are using loop to iterate each of the array element. So in the OR case, the time complexity is big O of n, and the space complexity is also big O of n because we are using extra memories to store the maximum value in the left and in the right. So here in the OR case, the space complexity is big O of n. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.